Welcome back to the channel. Just start over. Here we go. So we're saying, hey guys, welcome back. This is Equilibrium. Okay.
We should start the recording.
No, it's fine.
Okay, all right, Mr. Huff.
Okay, 3, 2, 1. Hey guys, welcome back. This is Equilibrium with Mr. Heller. Let's go. Subscribe to the channel.
Subscribe.
Shameless plug.
Yeah, subscribe, please. Subscribe to my school-issued YouTube channel that I'm probably not legally allowed to make money off of, but it's fine. No, I don't. How are you guys feeling today?
Cool. Yes.
Cold. It's chilly in here. It's Friday.
Is there video announcements today?
I don't know.
Maybe it's next week. I think it's.
They've only had like 5 days of school so far, so.
I'm not gonna lie.
Yeah, if you need a sweet treat, just go grab something out of the drawer. I understand that. There's like Lifesaver candy canes in there.
Candy.
Yeah.
Yeah, we're not taking watermelon.
Joe, you're taking the test, 6th period.
So,
Got something? What's the appropriate way to open a candy cane?
from the bottom, right here.
Or do you just break it? Yeah.
Yeah, you gotta go from the bottom, hold it by the hook.
They're J's.
Guys, I'm stocked on candy canes. I got those at the Everything Surplus.
No way.
20 cents for that whole box. I have a lot. So, yeah. I bought a lot. But I can't fit that much in there at one time. Okay. Where we left off was here. If you weren't here, hopefully you caught up on the notes. We were starting to ice things. Ice helps us get to equilibrium concentrations. Remember, I is standing for what? Initial, C is change, and E is equilibrium. Yeah. So here we go. We're gonna do one more calculation, then we're gonna keep moving. So K is very exciting. If you haven't watched the notes, K, this is our most important K, if you guys don't remember from the last notes. Yep. No, it's the same K. It's the same K. You guys remember that? Okay. Have you watched the notes? You'll see. You'll hear. All right. So K for the reaction below has a value of 55. This is the same K. Same K. At a certain given temperature, calculate the number of moles of HBr present in an equilibrium mixture that contains 3 moles of H gas and 0.45 moles of bromine vapor at this temperature. So here is my balanced equation. So what we're going to do is we are going to write our K expression first, which is what over what? Products over reactants. So my product, K equals concentration of HBr to what power?
2.
Squared. Because remember how the coefficient becomes the exponent? Okay. Yeah, Audrey remembers that.
I just know that from last time.
Oh. Well, that was sometimes. Now it's all the time. Over concentration of H2 times the concentration of Br2. So that's my K expression. And they gave me what? K. So I know that 55 equals, do I know any of these things? I know it has, what's that? K has no unit. K has no unit. 55, they told me at equilibrium I have 3 moles of H gas and 0.45 moles of bromine vapor. Do I know HBr? So that's going to be my what? If I don't know HBr, I'm going to make that X. So 55 equals X squared over the concentration of H2, which is 3, times the concentration of bromine, which is 0.45. And then all we have to do is solve for X. Pretty easy. We're doing one like this. Solve for X. Joe, do it for us, I'm sure. Who here has used Blue Book before?
Yeah, for the test.
Yeah. So I was just looking into Blue Book. The only thing I don't like about so your multiple choice part of the test will be on Blue Book for AP in the spring. The only thing I don't like about it is the equation sheet. You have to like scroll. I'll show you that when it gets closer. I don't know. Probably because I don't know. I wish my Facebook group is asking that question. They are asking, could there just be a printed equation sheet? It's only teachers. It's only teachers. What'd you get, Joe? 8.6. Yeah, that's what I got. I got 8.62 moles. 8.62 moles. Okay. So, when we're talking about K, we could say that the magnitude, guys, I'm actually like legit kind of locked.
No, I am too.
But usually after I say that, I unlock. So, the magnitude of K can give a quantitative guide to the amounts of products and reactants present at equilibrium. Present at equilibrium. Very large K values indicate large numbers of what? Think about how a K is written. If I have a large K, I'm going to have a large amount of products. Because products are where? On top, right? So I'm going to have a large amount of products. Does that make sense? Because products are on top. And reactions, if they're going to basically go to completion. So they're going to be like all the way to completion. Not all the way, but basically. Very small K values indicate large numbers of what? Reactants. You got it. Reactants. And reactions that hardly proceed at all. I'm waiting for CP Chem to get out of lab. So they're doing the 9 reactions. Yeah. So once they're out, we'll have lab either Monday or Tuesday. I'm not sure yet. I have to ask Ballsinger. Yes.
Wait, so you think if I made like a fake Facebook account as like a teacher, like
No.
could I infiltrate?
I say we go on there.
You would have to prove through your email, through AP Classroom as a registered. It's like locked.
Is that legit?
It's locked.
Oh my gosh, that's
I'll make a new one. I'm gonna just start trolling.
It's locked.
Hey guys,
User 1, 2, 3, 4. Is it like
Not
the
already and like
That's really good. Yeah, if you can purchase.
I'm just saying.
is it like the official one or is it just like that one?
No, it's like the official. Yeah. Someone like moderating it and like, yeah.
I'll be the
Um,
monitor.
You guys like share answers on there?
And then I'll.
What?
Then I'll get
Share answers on there?
Remember, we can't share answers. Like all the AP stuff is like locked down. If I would ever post something from an AP test on there, I could lose like my job, which I probably
Start, like,
wouldn't. But
posting the videos on
but people post questions or like ideas or.
Wait, we gotta do what we gotta do for that class.
Anyways,
Plus 3, we need it, let's go.
so understanding how K works, that will save your math life. So this is not a very good picture because if you look, it says in the diagram to the right that represents an equilibrium. Yeah. At a certain temperature. You can see that the H's are kind of darker. Do you guys see that?
No.
The I's are kind of lighter. Can you tell?
Yeah.
And the HI are the light dark. Here's the thing. What do you see a lot of? There's a lot. There's a large, here's what's important. There's a large amount of HI. That's all that's matter. That's all that matters. Which says what? Equilibrium lies in what direction of this equation? Equilibrium lies to the right or to the left? To the right. It lies to the right. Or you could say forward. Or you could say towards the products, which means lies to the right. So we know that K has to be what? If I have a large amount of products? Big. Because it's products over reactants. So K equals big. Flip the page. Flip the page. I got Oreo candy canes.
What?
Yeah.
That's a thing.
I don't know how I feel about it. Yeah, that could be your thing.
It's like chocolate and white, like, yeah. I got a lot. Because like candy canes never like go bad. It's just like hard candy, so. Well, you'll get to try it soon. I didn't try it. Flip it. So this can be done for gases too. So partial pressure, which you want to solve this, but I want to just make sure you see this. If I want to know the partial pressure of A, it would be the mole fraction of A, which you're not responsible for knowing how to do. This is one of the chapters we skipped. And everybody knows we skipped 2 chapters? No one noticed? Okay. Mole fraction of A, that should be inside the parentheses, times the total pressure. So if you ever need to calculate that in college, that's how you get it. Not super important. How do you get the mole fraction? Well, it's the moles of A. It's the moles of A divided by total moles. Isn't that wild? The mole fraction is the moles of an individual divided by the total.
That's almost like normal.
Yeah, it was wild. So this next part is so important. This was something I legit did not know till 2 years ago. When I graded papers 2 years ago, I found this out. I'm like, crap, people might have missed points on that. So here's what it is. Consider the following equilibrium. What would be Kp? Guess what P stands for? Pressure. It's the same K. It's just with pressure. So Kp for this equilibrium, I've got my big D's, big C's, big A's, all that back, right? It would be product, which is going to be partial pressure of capital C to, PPC to the little c, times the partial pressure of capital D to the lowercase d. 2 things prove that you know that this is a pressure. 1, you put PP for partial pressure. 2, you put it in parentheses. If you are dealing with gases and atmospheres, you really should do both. If you put brackets here, that's a concentration. Guess what? You're not getting the point on the AP test. I don't know why they're so picky about this, but they are.
So the parentheses mean pressure?
Parentheses are pressure. Think P, P. Parentheses, pressure. Also PP.
You don't want to put that.
Yes. Yes.
What if you put parentheses around the concentration
Parentheses, that's wrong.
instead of bracket?
It's wrong. You will not count that. So parentheses are pressure, brackets are concentration. So it's something small, but you'll remember it now because I just made a big deal out of it. But I did not know until 2 years ago that it was a big deal. So like I thought well, I bet some people lost like 1 point. It wouldn't be a huge difference between anything, but I didn't know. I didn't know that it could be the difference between a 3 and a 4. Who knows?
It could be a 3 to 2.
It could be. But luckily, those people's sacrifice in the past has made our lives better.
Yeah.
So,
People's future could have been entirely changed.
Trust me. They're doing well. No, we have shout out to the people who sacrificed that 1 point maybe of partial pressures. Yeah. Their sacrifice is our gain.
Amen.
So thank you for all those AP veterans. Yes. We should have an AP Chem Veterans Day. That'd be crazy. It'd be fun. AP Chem Veterans Day. Well, nobody died.
No, well, they're
Are you sure?
They're still. Oh.
No, trust me.
Wait, technically, Heller, what if someone forgot that because they didn't get taught it because they didn't go to as good of a school, and then they worked in something that caused
Trust me.
someone else?
Trust me.
Danny, what?
That's very dark. It's very dark. Over parentheses. Partial pressure.
Just the order of the C and the D matter.
No, it doesn't matter what order you do it in. Capital A to little a. Partial pressure of capital B to the little b. So PP is partial pressure. So write out your K expression for the following. So write the KP expression for this.
Are these always in equilibrium?
Yes. Yep. You won't write out a K expression unless there's equilibrium. So do that now on your own. Write the K expression for this.
And the exponent would be
The coefficient becomes the exponent.
Do you always have to write PP, or do the parentheses?
I'd prefer you write both.
Okay.
If you write in parentheses, write PP. Just write the K expression. Yep.
I didn't watch the notes yet.
Everybody right so far? Everybody have it right so far?
Let's go. Yes.
That's it.
Wait. Oh, so you lost an air.
Let us flip
Let us.
back a couple pages.
Are they about to cancel? Are they about to freaking?
I did not trick you.
Yes, you did.
No, I didn't. Trying to find out where this is. Side note number 1. KC expressions don't include what? There are solids in this expression. I wanted you to make that mistake, okay?
That is a freaking.
It's not a trick.
Who got it right?
Did anybody get it?
No.
Nobody. But I'd rather have you make the mistake now than later. Pure solids, pure liquids are never part of a K expression. So you don't include them. Because if I put a rock of iron in a cloud of gas, is that going to do anything to it? No, it's not.
So the little letters there. Coefficient.
This up here,
Yeah.
yes. The coefficient becomes the exponent. And that's a solid, that's a solid. If they were liquids, those would also not be included. Not meant to be a trick, meant to be a purposeful mistake. Yes?
So only gases would be included in this way.
In any equation. It's only ever gases, it's only ever going to be ATM or molar. You'll never have a liquid or a solid. Okay. Now, when equilibrium has not, this is about to get crazy, has not been established or is in the process of being established, we must use the reaction quotient. We've talked about this, which is letter Q, to determine what extent the reaction has proceeded. So, I know, to an extent. So, remember, we said that Q is the same as K, right? So you write the equation the same. So once again, Q would be concentration of capital D to the little d times the concentration of capital C to the little c over the concentration of capital A to the little a, and the concentration of capital B to the little b. Same thing, right? Yes? Okay. Did I write that right? Products over reactants? Yeah, that's right. So let me keep going. It'll make more sense in a second. I promise. Okay? It's the same expression, right? So the only difference between Q and K is that K is when equilibrium. It's when equilibrium has been established. While Q is the same ratio at any other time. Any guesses of when that time usually is? What's going to... Before, it's when it started, right? It's usually before the reaction has started. Because do I really care once the reaction has started? Like, no, right? It's going to be, I want to compare it before it started to when it's at equilibrium. Here's how these work. If Q is greater than K, so you have to start thinking about these related to each other. There are too many products. There are too many products. In the reaction mixture, and the equilibrium will shift. How? If there's too many products, it's going to shift it which way? Back to the reactants. If I've got an overload over here, it's going to shift it back to the reactants. Does that make sense? Think about like pouring water, right? That water, if I have too much here, it's going to want to flow back upstream. I don't know if that was a good example.
That was not.
That doesn't actually make any sense. Because streams flow downriver. That makes no sense.
I get where you're going.
All right?
You know, if you pour the water.
It's like a magnet.
Imagine like two containers with like a wall in the middle, right? If I add more to this side and I open up the wall, it's going to flow the other way.
Yeah.
Is that better?
Yes, that makes
Yes.
That was perfect.
Okay.
Now we know it.
So it will shift to the left or backwards. It'll shift to the left or backwards or back towards the reactant side. In order to reduce the product to the reactant ratio, in order to reduce the product to reactant ratio and lower it, where what equals what? Q equals K. Because if Q equals K, guess where I'm at? Right here. I'm already at equilibrium. So write that here. If Q equals K, I'm already at equilibrium. Yes.
So if, like, it's pushing the products back to the reaction, so the products just like start over in the reaction.
What do you mean start over?
Like, what?
What do you mean start over?
Like how it says if there's too many products in the reaction, make sure the equilibrium will shift, like, to the reactant side.
So that means there was probably products added. There was some kind of disturbance that made that happen. We're going to do that in lab so you can see that. What's up?
I gotta tell you, I really like my third period class.
Yeah?
Look what you got me today. A periodic table with all the elements.
What?
Yeah,
Wow.
isn't that crazy? One of my students in class. So cool. Well, a kid that graduated but has a little sister and said, give this to Mr. Knight. You guys remember Jason Deeds, real big beard?
Yeah.
Super strong guy?
Yeah.
Yeah. Yeah.
That's pretty cool.
Isn't that sweet?
Yes.
Yeah, I saw these on the TikTok shop and I never bought them, but
All right.
TikTok shop, here we go.
That is
isn't that
very
sweet?
cool.
Yeah.
Very cool. But you really came in here for a cookie, didn't you? Here's the thing. Mr. Knight came in here mostly to show me that, but he really just wants one of the cookies in that red tin.
What? There were cookies?
No cookies? Oh wait, and we yeah, there are.
There's like one or two left.
Why do you guys get candy canes until you get degrees?
That's
Cookies
true.
get degrees.
That's true.
Oh, I had a cookie last night, so.
That's very cool. I just love that I knew your true motive for coming in here. Because when I saw you, I'm like, he wants a cookie.
That's a cookie.
Okay. So, if Q is less than K, guys, we are gradually unlocking. If Q is less than K, there's too much. It's okay.
What are you guys doing?
We're talking about PPs, partial pressures.
Wait, not physical properties.
Not physical properties, PPs. This is a different type of PP. Yes. These are partial pressures.
Partial pressures.
Yes. All right. So, enjoy your. There it is.
Can you walk through this way so you can like walk
Oh,
through
yeah,
our
like
room?
that.
I just want to see.
It does have gold in there. I'm going to take it
How
out.
many cookies did you take?
It's a lump.
Yeah, it was stuck together.
I tried to take one. but
It's a
it didn't work.
sandwich.
So this will be the rest of my day. Isn't that sweet? Yeah, I know.
That's so cool.
Yeah.
They're like floating.
You want one?
I do. It'd be really cool. It's okay though.
Yeah, we're gonna give you like one of those.
Everyone
Just replace this. Apparently there's like.
We're actually gonna be getting you on that side.
That would be incredible. Backlit.
Chunks of uranium.
Yeah.
Apparently there's a store by Planet Fitness where there's like bulk stuff or things that were.
Everything's surplus.
Maybe, I don't know.
No,
They
but
said
this
it
is
was
like a
dollar
sketchy.
something.
$1.
$1.
That's where you root through the bins.
Yes.
So apparently this was in a bin at $1.
Wow.
I'm going.
What day was it? Was it $7 day, $2 day?
I don't know.
That looks like a mid like $3 to $4.
How much is this?
I don't know.
Someone Google it. How much are these birds by?
Just put it on your Google Lens.
Oh, I can do
I
that.
better pull it up.
All right.
I got it.
Anyways,
We were.
Yeah, we are.
if Q is less than K, we should have said something to Nathan like, you can fast forward for the next 5 minutes, but it's too late. So, all right. If Q is less than K, there's too many reactants in the reaction mixture, and equilibrium will shift which way? Forward. It'll shift right.
Oh, that's a $30 value.
Wow. That is.
All right, later.
It'll shift right or forward. To the product side, in order to increase the product to reactant ratio, once again, we're Q equals K. How do I remember this? I thought of this 2 years ago. All right, so once again, no. I just thought of this 2 years ago. If you think about it like a deck of cards, right? If the queen is less than the king in a deck of cards. Is that correct?
Yeah.
That's right. That means if Q is less than K, it shifts to the right.
Oh, I like that. I like that. I like that.
All right? If Q is greater than K, is that right? No. That's wrong, so that shifts left. All right? And once again, we already know if Q equals K, that is already at equilibrium. The main thing is, if you remember if Q is less than K, if the queen's less than the king, it shifts to the right, because that's right in a deck of cards.
That's really smart.
Yeah, 2 years ago, came up with that. See, once again, thank you. Thank you to all the former sacrifices who did not have that memory device. These things just come to me. They just come to me.
Like water slide.
What? Guys, my Instagram reels are not just AP chemistry.
Mine are. I said it to him to tell.
It's all good. It's all good.
Yeah, you're Kelsey.
See, you're turning into Chem. You're not even Kel anymore. Wow. All right. Here we go. In a situation where two reactions occur with a common, I just flipped it the wrong way.
I know that was funny.
Guys, we gotta start working on the t-shirt. I'm just saying. This needs to say AP Chem t-shirt ideas and start like listing them out. Okay. So if there's a common intermediate, I can't say much about this yet because Joe still hasn't taken the test. But that last page was a disaster. Okay. All right.
Take it off.
I felt so good about it.
Yeah, just like a rice.
It wasn't for you, Audrey. Okay. For everybody else mostly. With the mechanisms. That was supposed to be so easy. All right. It was only 6 points.
Mr. Heller, I
Yes.
know I did so good. I was so confident.
I don't remember what you got. but-
What the heck? I thought I ate that up.
Okay, well,
There's no way I
once
got
I
it.
show you, you're gonna be like, oh.
Yeah, it's
Yeah. Don't be mad. Okay. Here we go. Step 1. So step 1 has a K, and step 2 is also gonna have a K. So my overall K, I'm gonna get rid of what is canceled out, which is gonna be my what? Intermediate. That's an intermediate. So when I get rid of that, I have H2CO3, 2H plus CO3, 2. So if I was going to write a K for all these, stage 1, K1, stage 1 would equal, I don't know why I did it like that, concentration of H plus, I'm locked, times the concentration of HCO3 minus, HCO3 minus, over the concentration of H2CO3, that'd be K1. K2 would be concentration of H plus times the concentration of CO3 2 minus over concentration of HCO3 minus. So overall, what I'm honestly doing is I'm just doing what? I'm multiplying these together, right? Because H on top times H on the top is what? H plus squared. Agreed? Yes? Also, look here. It's still products to the 2. Times, what else do I have? What am I going to lose? This is going to cancel out. Yes? So, times CO3. I'm just showing you the Y, 2 minus, over the concentration of what? H2CO3. So you can use K's to figure out what the overall K is. But the overall K is just the what? I just said it's the what of K1 and K2. The product, yes. It's the product of K1 and K2. So you can manipulate K and Q. You can do some weird things to it. So here's one. N2O4 is in equilibrium with 2NO. What would the original K expression be for this? Concentration of NO2 squared, right, over concentration of N2O4. That would be my original K. What if I reversed it? So if I reversed it,
It'd be the reciprocal.
ooh,
Why can't you know?
yes.
All day.
The new KC, right, would have to be 1, put it over here. It would have to be 1 over KOG. Agreed? Yes, it'd be 1 over my original K. So my new KC is just going to be flipped. So it's going to be the concentration of N2O4. Let's see if Derek can get the next one too. He's on fire. Over the concentration of NO2 squared. What if it is halved? If the equation is halved, so I take this equation, I have it. So now I have 1/2 N2O4 is equilibrium with NO2. Yes. Oh my goodness.
Wow. What is KO5?
KOG. That's OG. OG. Did you just yell out a random math term?
No.
Exactly, because K to the 1/2 power is the square root. Square root of KOG. That's OG. Or it would be K, right, to the 1/2 power, right? That's the same thing. So my new K would be concentration of NO2 over N2O4 to the what power? To the 1/2. To the 1/2. All right. What about triple? What if I triple everything?
You just multiply the top, the NO2 power, and then just put a
So here I am, oh, I'm sorry.
6
I'm doubling it. If I double this, right, what's it going to do? It's going to be KOG
to 4.
squared. My new KC would be concentration of NO2 to the 4th over the concentration of N2O4 to the 2nd. So in other words, it's KOG squared. Tripled would be KOG to the what? Yes, it'd be KOG to the 3rd. So there will be a problem on the homework that's going to be like this. They're going to give you a K and have you like just change it. It's easy. You guys especially are just like crushing it. Oh my goodness. This is very exciting. We have reached probably the most important principle in chemistry for the rest of the year. Les Chateliers. Who here is in French? Say that very French-like. Do it. Les Chateliers. Oh.
No, we don't do that.
Do it again.
Can I put it in the, like,
I just want to hear Kel or Haley say it.
you gotta get
Do
like,
it.
the throat sound.
Les Chateliers. Yes. But it's not Les Chateliers, okay? Okay? Yeah. One time, I need to have Madame Force come over here and just be like, boom, tell me what this is. But anyways,
Like she just burst through that door.
that'd be awesome. Les Chateliers! That'd be incredible. Anyways, this is so important. I know.
These are so unhinged.
We went from locked, we just gradually go downhill.
Every time you say
I know. I need to stop saying that. Yes. Probably not. I wasn't planning on
There's
it.
like 50,000.
Yeah, good, because there's like.
There's 7 left.
There's 7. Yeah, we're not finishing that. Okay. Remember, this is all of Unit 7, which is the biggest unit. Right? So, Le Chatelier's principle states the following. When a stress,
I love stress.
and think about this in terms of yourself, is placed on a system at equilibrium. When a stress is placed on you, what do you want to do to that stress? Do something to relieve it. Right? Go to sleep, cry. Okay? Those could all help. Go spend money. Get a coffee. All right? Just revenge shopping. All right?
Shopping is there.
There will be a shift there will be a shift in the position of equilibrium. And the shift in the position of equilibrium to reduce that stress. So the shift occurs. Why? Because the stress will cause what to change? Q. It'll cause Q to change. And what will have to change because of that? The equilibrium has to shift to bring Q back into numerical agreement with K. You got it. So there's a few different types of stresses. Stress 1 is addition or removal of products or reactants. We've talked about this a little bit. Okay? So if I have, so A, let's just do letter A first. It will shift to the other side if something is added. We were just talking about that, right? So if I add products, it's going to shift to the reactants. If I add reactants, it's going to shift to the products. Okay, B. If something is removed. If something is removed, comma, look at that. I used punctuation. I know. It will.
Oh, shoot,
This is B, still on number 1. It will shift to the side it was removed from. It was removed from. It was removed from. I do. Oh, Audrey's got your back. So that's the easiest one. None of these are hard, but that's the easiest one because it makes the most sense, right? Yes? If I remove reactants, right, what do I have more of then? Now I have more products, which is going to shift it to the reactants. If I add reactants, now I have more reactants, which is going to shift it to the products. Okay. What about pressure? What about pressure? So let's say the pressure is added. So when pressure is added, it will shift to the side with what? With the least what? Number of, you're right, moles. It'll shift to the side with the least number of moles of gas, which would be the side with the least pressure, right? What do gases do? Gases like to flow. They do what? Diffuse. Who said that? They diffuse. So if you had this equation, 2 carbon solid, warning, plus O2, warning, gas, is in equilibrium with 2CO gas. There's an equation. So in this example, if I add pressure in this situation, which way would it shift? I heard left, I heard right. I'm adding pressure to the whole system. I'm not adding pressure to one side. It will shift to the side with the least number of moles of gas.
Oh, is that a solid?
That's a solid.
Carbon's a solid, so it's gonna shift to the left.
So you were right, Henry. I have 2 moles of gas on the right, only 1 on the left. So it's going to shift to the left. Yes. So if I add pressure in this situation, it's going to shift left. It's going to shift left. Okay, what about this? Now I have to think gas laws. What if I increase the volume? Which way will it shift? Think about it in your head. Don't say it out loud. Closed system, increasing the volume. Think about this in your head. What law do you have to think first? Whose law is that? Boyle's law. If I increase the volume, what's going to happen to my pressure? That means my pressure is going to be lower pressure, right? If I lower the pressure, it's going to shift to the side with the most amount of goals, because the mole is the goal. So this way, it's going to shift to the right. It's going to shift right. Now, what if I add just an inert gas, like xenon or like a noble gas? Is that going to do anything? No, because inert gases don't interact, right? So if it ever says add an inert gas, no change. No change. Inert. So something that's not reactive. It's essentially going to be something that's like a noble gas. Okay. Well, in an inert gas, it's just going to hit it and bounce away. It's not going to change the pressure because it doesn't want to interact. Okay? What about heat? What about heat? So we're not talking about pressure anymore. Now we're just talking about heat. What's going to matter for heat? If it's what or what? What kind of? If it feels hot or cold, it depends on if the... Yes, it depends if it's exothermic or endothermic. So, here we go. This might make more sense now when I do it like this. If it is exothermic, yes, I think of exo as exit. If it's exothermic, what symbol goes with exothermic? Let me zoom in a little bit. If it's exothermic, it's usually a negative symbol, right? Because it's giving heat off. Yes? What you're going to do is you're going to add heat, put heat in quotations. We're adding heat, okay, as a product. We're going to add heat as a product. If it is endothermic, which is going to be a positive symbol, we're going to add quotations heat as a what? As a reactant, because it's taking heat in. You can add heat as a reactant. Correct, because exothermic is letting heat off. So to us, it feels hot, even though it's a negative sign. Endothermic feels cold, because it's taking heat from your skin into the system.
Oh, so like that's why like when you touch a hot pot, it's the transfer of heat to your skin and that's
Exactly.
burn.
Yes. So here's an equation. We're going to have 2 FeCl3 plus 3 CaOH2 is in equilibrium with 2 FeOH3 plus 3 CaCl2. Leave a little space. And then this would say that it is negative 36.3 kilojoules. Remember how we used to like figure those out? We could figure out like kilojoules per mole. Yes. So they would give you an equation like this. Which side am I going to write heat on? On the reactant side or the product side? On the products, because I'm giving off heat, yes? So what I would do, I would literally write plus heat. I write it as a product or I write it as a reactant. So I could do a couple things. If I add FeCl3, which way is it going to shift? This has nothing to do with heat. If I add FeCl3, which way is it going to shift? I'm adding reactant, so it's going to shift right. Yes. That was my left, but you're right. I got you though. If I remove CaOH2, which way is it going to shift? Left. Because CaOH2 is a reactant. Whenever you remove, it shifts to the same side you remove it from. It's going to shift left. If I increase temperature, which way is it going to shift? Where did I write heat? What am I adding if I increase temperature? I'm adding a what? I wrote heat as a product. So I'm technically adding a product if I'm increasing the temperature. Does that make sense? So if I'm increasing the temperature, I'm adding product, therefore it's going to shift to the left. So when you're dealing with temperature, think about temperature literally as one of the products. Temperature was a product, right? Because it was negative. If I'm increasing the temperature, I'm adding product, which is going to shift it back to the left. Are you okay with that? Kind of? If this would have been positive 36.3, I would have written plus heat over here in my reactants.
Why is, so that says negative, so is that?
Negative 36, that means I am giving heat off. If I'm giving heat off, heat has to be a product. If I'm gaining heat, I'm taking heat in, so I would write that as a reactant.
Okay, got it. I think increased temperature means negative positive.
If I'm increasing temperature, that means I'm adding heat. That's all that matters. And my heat on this one is a product. So if I'm adding heat, it's going to push it back the other way. Because think about it. If something is giving off heat, right? And I'm adding heat, it's going to work against it. Right? It's going to make it go the other way. Okay? Yes? Okay. So, note, increase in the total pressure. See, you can tell I wrote this. By adding an inert gas. Has no effect on the partial pressures of gases, so it has no effect on equilibrium. Has no effect on equilibrium. So here we go. This is the Haber process, not something you have to know, but I have N2 plus 3H2 is an equilibrium of 2NH3. Delta H is negative 92 kilojoules per mole. Where am I going to write heat? Yes. I'm going to write plus heat. And this gives you several different changes. If I increase the pressure, it's going to shift to the right. Why? Because on the right, how many moles of gas do I have? 2. On the left, how many moles of gas do I have? 4. Shifts to the side with the least amount of moles. Moles. The mole's the goal. If I increase temperature, I'm technically adding more what? Product, which is going to shift it to the left. If I increase concentration of nitrogen and hydrogen, I'm adding both what? I'm adding nitrogen and hydrogen, which are both reactants, which is going to shift it to the products. If I increase concentration of ammonia, it's going to shift it to the left. So this is just an explanation of why. Cool? Okay. I think that would be a good place to stop.
I agree.
Because we'll review with this starting the next day. So we'll review that starting the next day.